As you probably know, human beings have 5 senses. We can see something, we can smell something, we can taste something, touch something, and hear something. These senses collect specific information about the world around us that is later gathered together in our memory to create mental representations of an object, of a person, of an animal, etc.
For instance, imagine a toast. Your senses collect information about all the features of it. It is not only that you know how it looks like, but also how it tastes, the smell it has, the texture of a toast, and even how it sounds when you're chewing one. So, as you can see, your memory has stored all the input as regards to toast from your different senses.
Now wait, you're probably wondering what may happen if you lack one or more of these senses. What your brain will do is to put on the alert to the remaining senses in order to compensate for the missing one or ones. Therefore, since your brain is not receiving one or more features of the mental representation of an entity, the remaining senses will intensify their work and replace the missing information.
Now, close your eyes and listen carefully to these words. Red, car, hammer. Now, open your eyes. As we have mentioned, there is strong belief that when one or more senses are missing, the others try to compensate for the non-working one. And this is a fact. But specifically, one of the senses to which we rely more is sight. So you may wonder what happens in a person who cannot have access to these senses.
With again et al. Answer to this question in their paper Short-term Memory and Working Memory in Blind versus Sighted Children by saying that touch, memory, and attention skill have been found to compensate for the absence of vision. The authors have remarked that blind people have been on the focus of attention for several years. However, authors highlight that little research has covered what happens in blind children who are experiencing the world for the first time. The authors in this paper specifically have focused on finding differences in short-term memory and working memory performances of blind versus sighted children.
First of all, authors of the paper start by describing in detail how the short-term memory and working memory operate. Working memory has been described as an active system for holding and manipulating information over a brief period of time during the course of ongoing cognitive activities. It also makes more demands on the central executive system, which is the system that controls attention. Short-term memory is a more passive system in which information can be stored for a very brief period of time.
The study consisted on evaluating separately the short-term memory and working memory on blind and sighted classmates. So as to evaluate the short-term memory, experimenters realized 3 tasks. First, the digits spanned forward. This consisted of the repetition of the sequence of digits. The second one was called 15 Test Word for Children and consisted of a memory game in which children had to recall 15 words. Finally, the third task was called Learning Names, in which all children were blindfolded and by touching an object they had to guess the name.
To evaluate the working memory, authors presented 2 tasks. The first task was called Listening Span Task, in which the experimenters read aloud 2 sentences and children had to decide if they were true or false. The second one was called the Digit Span Backwards and consisted on the repetition of digits by the experimenters, while children had to retain and then repeat in the reverse order.
As regards the results, these showed that blind children outperformed sighted ones on both short-term memory tasks and working memory tasks. It was not a surprise for the authors to discover that blind children had better performances on short-term memory tasks. However, what was new for them was the fact that blind children also surpassed sighted children on working memory tasks. In previous studies, sighted children would always outperform blind children in working memory tasks. However, authors suggest that further research is needed since the tasks for working memory and short-term memory were mainly auditory and spatial.
When coming to the pedagogical implications, we are able to acknowledge that this study has helped us to understand that although we can find students lacking the sense of sight among sighted individuals, we can create an inclusive environment. Since it has been proven that blind children have better performances with auditory and spatial experiences, we can implement more activities with listening comprehension, audios, and different recording. In addition, as blind children have excellent results with the spatial experience, it can be implemented total physical response activities in order to improve the acquisition of knowledge and offer students the same opportunities.
Do you remember the words we asked you at the beginning of the video? If you do, that's great. Your sense of hearing was compensating for the lack of vision. If you don't, that's probably because 1. You didn't close your eyes, so you had double input, both visual and listening. Or 2, if you don't remember the words, it's because you knew that when you open your eyes, your sense of vision would be back again.